Hello, good morning, good afternoon, good evening. Welcome to another episode of IoT Tuesday with your study Samuel Ajrani. We do this every Tuesday, just demystifying everything about IoT, Internet of Things, AI, smart things, you name it, you think about it. If this is the first time you're joining, please share. Oh, thank you so much, Ellie Clean, always making my day on the stream. Thank you so much for joining us on the stream. We do this every Tuesday, trying to bring IoT goodness to you. Welcome. If you're joining us, just say hi. You know, I would I would acknowledge you on the show. Let's say hi. Let's know where you're joining us from, and let's have a conversation. And also, whilst we interact on the show, we learn. Today we're going to take off from last 2 weeks because we didn't come last week due to some technical issues. But we're going to continue from last 2 weeks where we're going to see communications using LoRA. So one will be a sensor node and one will be a receiving end. And then also we can send commands from one node to another using LoRaWAN. If this sounds like something that is of interest to you, as you always know, let's go for our montage. We will be right back. Stick and stay with me. Yeah, awesome. We're demystifying everything IoT. Yeah. We're demystifying that. Thank you again for joining your stream. This is IoT Tuesday. We'll see you. We're yours truly, Samuel Ajrani. If you're joining us, just say hi. We will acknowledge you. And before we continue, I want to take a moment to say thank you for joining us. And then if you've not subscribed, please hit the subscribe button down there, and if it starts too much work for you to do, just scan the QR code up there, and that will connect you to my YouTube channel so that anytime we release a new video, you will be the first to know. So what are we doing today? Today we're going to continue from where we stopped last 2 weeks, but before then I have something to show. Today is Unboxing Tuesday. Yeah, Unboxing Tuesday. So I have a few kits around which came in. I'm going to unbox them. We're going to talk about them for a while, and then we'll jump into today's session. So let's go to the bench. Let's go to our bench. Let's go to our bench, and see what we have there. Just a sec. Let's get you to the workbench. Awesome. So as you can see, we have a lot of goodness happening on the workbench. I will try to take them one after the other, and we'll talk about them. We have all these things coming in. We have the XIAO E5 development kit, which is from Seeed Studio. Again, disclaimer, this is not a paid promotion. This is something the channel has purchased, that so our review is unbiased. It's just our own opinion of it. And yeah, I know you noticed that we have a lot of Seed stuff going on the show because we love to use Seed stuff. So we're gonna dissect this, open and see what is inside. I think we have a copy of this. This is running on, I think this is running on ARM Cortex. We have one. Let me see if I can pick it up from here. Yeah. So we have one here. Let me put this here. Yeah, we got yeah, a lot of goodness indeed. And yeah, a lot of these things will be manifesting a lot next year, which is a couple of weeks to 2024, specifically on the Accra IoT user group. These are some of the things we want to be doing, so very practical, hands-on. So if you don't have the kit, you want to learn how to use it, just make sure that you join the user group, and then we'll publish the date and venue. You can join us, and you can hands-on yourself experience how to use these things. So we have one here, which is the E5 dev board. You can see the antenna. So this one is almost the same thing in this box. So I won't stress it trying to unbox this one today because we've seen it. We just wanted to do some, master and node setup. So I will leave that there. So this we've seen, and if you just for the sakes of those who probably doubt that is the same thing, we just open this up here. Give me a sec. So let's do this. In here. Yep, so there you go. So you see it has the antenna. See the board itself, the same board right here. So I can take this off. And actually, let me connect this. Yep. There we go. So there you go. Yeah, and the cool thing about this one is it has you know, the battery thing, so you can easily plug that in here. There you go. Right, so now we technically have two of these, right? We have two of these, so one can be master slave, one node, you know, so we have two of these. So yeah, so that's it for this one. So I'm just going to put them somewhere here, and then we'll sorry, and then we're going to discard this box. We're going to throw it somewhere. So first unboxing done. Let's keep it somewhere here. So yeah, so that's the first one. The second one I want us to quickly unbox and take a look at is also a Wheel WM1110 development kit, which is also a LoRa development kit. So let's go ahead, take this off. So parking list has one dev board, one antenna, one GPS antenna, solar panel. Oh, this sounds like interesting. So there's a Fusion development board. It's got RF52840. It's got the Semtech LoRa on it, long range wireless communication. So this has GPS, Wi-Fi, Bluetooth for location tracking. This is going to be awesome. So yeah, we might have sessions where we talk about this. Actually, let me see if we can pull this up right here. Let's bring this right here, people. And yeah, if you have any questions, please let me know. I can try to answer them. Figuratively speaking, I'm live on Tuesday. I know, right? But the truth is that these unboxing sessions sometimes can be a bit stressful, because I'll give you an example. When I was unboxing the when I was unboxing the Oculus, right? What happened was that I had it for a long time, and I just wanted to unbox it, but I had to wait to do that on the show. So that was a bit of sometimes, you know, you have it in, but yeah, but thank you so much. Hopefully we can grow, so we can grow the channel very well, that we can get a lot more kits and a lot of stuff to, you know, to unbox on the show. Yeah, so let's open this up. Sometimes these things get a bit, okay, there you go. So let's see what's inside. Oh, blank? No, it's just a screen. Okay, this is a protective film. So this, let me bring this a bit closer. So we have this, and so I think this is the dev board. This is the GNS or GPS antenna. And oh yeah, it has a very small solar panel here. So let me take this out, and yeah, feel free to drop your questions. So yeah, so this is a solar panel, as we can see, that connects to the board. So we're gonna put this here, and then this obviously is I don't know if you can see that well, but this is a GPS antenna. Yeah, so this is a GPS antenna, you connect to it. Let me put this on this side, and then the moment of truth. Okay, so this is how this looks like. So this is how it looks like. It has two antennas here. One is the GSM, and so one is a GSM, one is the LoRa antenna. Strangely, it says there was, according to the parking list, we're supposed to have one LoRa antenna. Oh yeah, there you go. Oh yeah, I didn't see that. All right, so yeah, there's a LoRa antenna here. So the LoRa antenna will go here, and then the GPS antenna will go here, and then yeah, and then you can put 3 1.5 volt batteries at the back, so self-powered. Or I believe that will probably, I don't know, we can try to put, okay, so this is interesting. So this has a supercapacitor at the back. So I believe something that has to do with using the, you know, some clean power to charge it. Cause this panel, this solar panel here, would go into the power port here. So I believe, yeah, there's some power management thing going on here. So probably we could even put a rechargeable battery here. So rechargeable battery down here, and then we can connect yes, our LoRa. Let's go ahead and connect the LoRa. There we go. And then here you have the GSM module. All right, so that is the second unboxing of stuff. Yeah, we can put all of them in there. This, I believe, has this one here. All right, so yeah, interesting times ahead of us. So let's just put them back in here. Can put these. All right, so that is the second kit we are unboxing. I don't know what you think so far of the two kits we've unboxed. Let's put this here. Now I have a few more things we have to unbox. Well, they're pretty much the same, so I'm going to unbox one each, and then we're going to talk about it, and then we'll. So this for me is let's do all the Seeed unboxing, and then let's come to the ESP unboxing. All right, cool. So this here is the LoRa One Seeed Studio tracker, right? This is one of the very interesting trackers from Seeed Studio. Is a sense cap tracker. I'm trying to open the sheet for you. All right, so this is packed with a lot of goodness. It's LoRa powered, has GPS, a lot of interesting things. But just to show you how what the cool stuff is on it, let's do this. Give me a sec. Let's go to the desktop. And let's go and watch this video, and then when we come back, we'll talk more about it. So just stay with me in a bit. Stay with me.
Hello everyone. This video will show you how to effectively use the SenseCap T1000. The video will cover the following topics. First part, basic configuration. Help you hands-on quickly know the basic concept and check the tracker's location. Second part, advanced configuration. This will help you use most of the tracker's advanced features. Third part, product tips. I'll introduce the LED indicator button and buzzer and explain the user experience with the charging cable as well as how to update the software. Next part, troubleshooting. We'll discuss common issues like not being able to get a location, the device going offline, and how to force a restart. For this demonstration, I will use the SenseCap T1000A as an example. This model comes with built-in temperature, light, and motion sensors. SenseCap T1000 basic configuration. Before getting started, please make sure you have coverage from a LoRaWAN network such as Helium, TTN, or other LoRaWAN networks. Without LoRaWAN network coverage, the device cannot send data to the cloud. The easiest way to use a tracker is with the SenseCap LoRaWAN gateway and the
So sorry about that. I've been told the sound is a bit low. Let's see if we can. Let's see. Thanks, Shelly Cream, for that update. Let's see if I can get the sound. It looks like the video itself has a very low. So you know what? I'm going to pull out for a different video. Yeah, where we go. Let's see. So this is not a, you know what, let's talk about it. Let's talk about it briefly, and then because that makes it easier for us, so we don't spend time on it. Because today we have a couple of things to show. So this is a very interesting tracker from Seeed Studio. Like I mentioned, it is how do I put it? It is LoRa, so it requires a LoRa gateway to send the data to the cloud. Interestingly, it has a bunch of sensors. So there's temperature, it has temperature, It has a location tracker. It has an emergency button here, and then it's one of these magnetic trackers. Now, and the cool thing about this is that it's, you see the way it is, it can be used as a tag, as an asset tracking tag. It can use GPS, it can use LoRa, but preferably it requires you to have some LoRa setup or LoRa configuration. It's interesting. Some of the use cases, like I mentioned, would be, basic use case would be asset tracking, right? You have some assets you want to track. So I'm going to be a very yeah, so that's what's making the noise right now. Check this, it's trying to connect. Yeah, so I just shut it down. Now, if I'm trying to be very controversial right now, we know next year's an election year, upcoming election, right? So we want to probably we know the issues with ballot boxes and people trying to take them. Not to sound too political, but yeah, this could be one of the things we can drop them in a ballot box or attach them to a ballot box and be able to track them. If we had a wider LoRa network or using satellite, we could track it. So, and this gives us the capability to do that. Also, in an office space, if you have a LoRa, connectivity in your office space, you could use it as an idea way to identify or track your asset, and also people or human tracking. You could do that. So it leverages the magnetic pin. So it would. There you go. So look at that. So to the back, let me remove this, and then I'll show you how that. So at the back, because it's magnetic, there you go. So sticks in the back, and then you can just put it in, just plug it in, and then it will charge. So we have two of them. I'll be testing them because you remember we showed you a mile side LoRa gateway we will be deploying that also on the show. So once that is deployed, I would have the tracker on me and move around, and we can send the data and sound. Awesome. And then we can send the data to the cloud and see track where I have been. So that is let's go back to our bench. Let's go. So that is for the LoRa One tracker from Seeed Studio. So a lot of Seeed Studio stuff. Then there we have the Wheel Tracker 111 development dev board. All right. So this tracker is a development version of what is inside this one. So pretty much it's the same hardware, the same set of components that is in the tracker, this one, that having made into a development board in this format, so that you can literally connect sensors or connect things to it to explore. So the same way, if we connected this and powered it and move around in a LoRa, LoRa covered area, you still be able to send telemetry and stuff to the cloud. So this, because we can't break this apart, or I mean, not that we can, we could, but we don't want to break it apart. We have a dev kit for it that tells us or shows us the makeup of it, the component of it in there. So these are the cool stuff that we have, that somewhere next year on the show we'll be showing how to set it up. You see me test it, move around, and I'll share you content with it. Then finally, they are the same boxes, so I can literally put one put one aside, and then we can talk about this one. So this is coming from the manufacturers of the ESP chip, Espressif. This is one of the dev kits for a baseboard that supports the Martha thread, and that whole new segment protocol, right? So we have this, we have a couple of them in-house. This is the baseboard, as you can see. Interesting board that allows you to create a bridge, a Martha or thread bridge that allows, if you have devices that speak Zigbee, Bluetooth, Wi-Fi, Z-Wave, you can use this as a bridge for them to speak to each other. You know that device communication, if you have Zigbee specific devices, they only speak to Zigbee specific devices. They can't cross the carpet. So in this case, I could have a Zigbee button that can control a Wi-Fi bulb. in the same way, yeah, you can put one in my house. In my house. Yeah, don't worry. We have, I think I'll have to bring one of my thermal engineers on the show. We'll talk about crafted climate. We are actually building environmental sensing kits, which tracks temperature, humidity, particulate matter. And yeah, we have the GSM powered one and we have the LoRa powered one. So don't worry, definitely, we've already registered your seat. We'll give you one to put in your house and we can send the data to the cloud. So this allows you to build a bridge that you can use to let Wi-Fi devices speak to Bluetooth devices or LoRa devices. Sorry, so why that's Wi-Fi or Wi-Fi devices to speak to Zigbee, and then vice versa, and then Matter and Thread as well. So let's be on the watch out for this. This is just to unbox it to let you know we have it, and then it's going to show up as part of the things that we will be working on for next year. So if you have any questions and comment about what you've seen, let me know, and then in the course of the show I can share that with you. So let's come back on track. So today we're going to show you the setup for LoRa communication. All right, so I'm going to go ahead and set this up so let's go to the bench. I'm going to set up the bench and show you what we have here. There we go. So as you can see, we have two setups here. I don't know how I'm going to do this. Okay, I think I should use one of, actually, let me use this. I could actually use my phone. You know what? Yeah, I'm going to do it this way. Cool. So it's easier for you to see. All right. So let's talk through this. So I shared the schematics for this in the last two episodes of the IoT Tuesday. So what we have here is an ESP32 and then another ESP32 on this board, which you can see right here. Now, all we have on this board, I'll share the schematic shortly. All we have on this board is technically the LoRa module, and then your ESP, and then we have this traffic light LED here, right? So I've just set this way so that you can see the changes when I do it. Then on this one, what we have here is also an ESP32, 3 buttons, and then we also have another LoRa module up here. So what we've done is pressing these 3 buttons, red, yellow, and green, will automatically turn, depending on the color you press, will turn on the LED. Now, this is to simulate that we have these two setups speaking or communicating via LoRa, right? So this one, the one with the button, could be in the control room somewhere within the LoRa range, and then this could be the device actually on the ground, right, where we can control it. So I'm going to connect this up, and then you see me, and then I'll share the code. We'll talk through the code, and then we'll do, if there's time, I'll show you a similar one leveraging on the Seeed Studio setup, which I also have here. So let's go ahead. Let me pull this up, and yeah, don't worry, we have the code. I have the code in the GitHub repo. So today I'll share the GitHub repo. If you want to try it, you can go download the code, play around with it, and do stuff. So don't worry about it at all. So let's go let's see. Let's go to my repositories on GitHub. Communities, not this one, not OmniHealth. Yes, IoT Tuesday. Let's go here. And then we have this. Okay, hold on just a sec. Yeah, and whilst I'm trying to pull out this, if you have any questions, please let me know. Drop them in the chat and I would answer it. I'm trying to pull out my, where is that? I'm trying to pull out the code for the IoT stuff. Just a sec, in a bit. Let's go. So it's quite simple. Think about the use cases. It's not just you know, just traffic lights in the traffic light situation, but then imagine you have, you know, you're doing a smart farm, right? You are doing a smart farm, and then let's see, GitHub repo. So I'm assuming you have a smart farm, okay? Still haven't found any simulator that has the LoRa. I don't know, did we? I think we found, no, I don't think we found one that does the LoRa. We didn't. I think there was is it Answer Simulator or something we saw, but we've not really tried it. Let's see. Let's see. In a bit. All right. So, okay. Sorry guys, just a lot of things running. Okay, so I'm gonna go to the desktop here. So basically, once we find it, I will definitely share that with you. Okay, so don't worry. Let's do this. Let's go ahead and show the schematics first. Let's download the schematics. There we go. And then actually let me just fork this whole repo here, or let me just clone it. So go to Git, copy this. Let's go to our console. Let's do dev. I think we have an IoT folder. We have an IoT folder. Yep, there we go. So CD IoT. Hold on. How do we call it? IoT Tuesday. Yep. What? I know, right? Sorry. Let's do this. Huh. I did something. All right. CDI. Okay. You know what? All right, let me do this. Just let me try. I don't know what's happening here. Just give me a sec. File system. Okay, let's bring this here. IoT Tuesday. D. Yeah, I know why it's not happy with us. Let's go to dev. Let's go to IoT. Let's go to IoT Tuesday. Yep. Okay. So I'm gonna copy this and then we'll do this. Don't worry. What does it say? A position gonna be found. Accept arguments Tuesday. Linker. Come on. Come on, Chloe. A lot of red lines. We're like, oh, what's happening? You're having a meltdown. Okay, you know what? Don't worry. We're in dev, right? So let's do mkdir IoT IoT underscore demos. Oh, just pretty much. Let me just create. Don't worry. IoT demos. Awesome. So CD IoT demos. There we go. And then let's do this. So I'm going to copy this. So git clone this repository into this. So I have, so I'm going to organize it in the episode number so you can know what that is. So dir, we have all these things here. So we have the groove, and then we have the LoRa traffic light. So I'm going to go ahead and open the LoRa traffic light. So there are two code bases. We have the transmitter and then we have the receiver. So the transmitter is the buttons, and then receiver is the traffic light. All right, so let's go ahead. So if I do cd, let's do this. Let's get this going. cd LoRa traffic light RYRL 998. So wow, there's something really crazy going on today with my code. You know what? Let me just bring this here directly. Let's bring this here directly. So dev IoT demos. Yeah, so we're using the RYRL 998 LoRa modules. That's what we're using for this one. So let's go ahead. Let me open my LoRa. So two codes, which I'll go to the board, I'll connect them, see how that works. So let's go ahead and I'll walk you through the code. Why is this thing showing? I should come here, and then I'll walk you through the code of how, you know, we built it. So there we go. I'm going to okay, so while that's going, let's go to the bench and let me go and connect the setup. So sorry, let's do this. Let's do this. Let's see. Okay, so let's do this here. So we have our traffic light. So what I'm going to do, I'm just going to connect them to the power. So this one here, this one is USB-C. Where is our USB-C cable? I think we have a USB-C cable here. So yes, so we're just going to connect, and then let's give it power. All right, so the first one is powered. Now we need to power the second one, I think, which is just which is this one. I mean, this is just so let's power it. So as you can see, this is also powered. We've powered this one on. All right. Yeah. So so there are some new ESP32 boards that are USB Type C. So yes, you can leverage one of those USB Type C ones. All right. So now we have all the two powered. So this is a transmitter, this is a receiver. I'm going to adjust it here again so that you can see the code is already deployed on it. So I'm going to try with a red. And then you see that as I press the red button, the red light came up. I'm going to try with a yellow. So I'm going to press the yellow. And then the yellow one is on. And I'm going to try with a green. And then you can see the green light is on. I'm going to try with the red again. So we added a little bit of a debounce. So because it's LoRa, we added a little bit of debounce so that it can, not a delay, but just to make sure that, we are not dropping any packets along the line. And then the same thing with yellow. And then, the yellow one will go on. And then if I do the green, I press the one for green, release the button, it will send the signal for the green one. So the same way, to the red, and I release the button, the red one will come. So what's happening here, as you can see, there isn't any, all I have done is just to power them up, right? So it's just, we've already deployed the code onto the LoRa, the two ESP modules, and they are leveraging LoRa, this LoRa module, to send and to receive via AT commands. So we send an AT commands from the transmitter, say, hey, red, and then that goes to control the red. So think about this. This could be anything. This button could represent any trigger, right? And then the LEDs could represent anything that is supposed to act on it. Right now, we're just doing device to device communication right now, or device to device setup. In the next subsequent episode, we'll now do device to gateway, which is where we'll see how to set up the mouse side gateway, so that now, instead of this coming straight to the device, it will probably go to the gateway, and the gateway can send it back to the device. So we're just trying to illustrate something here for you to understand that, yes, you can have the communication between one node to another. So that's node to node or device to device. That extremely is possible, right? Then imagine you have a bigger setup or have a fleet, right? Then you can do node to the gateway and gateway to whatever it is. It doesn't mean that is the only thing you can do. Well, so the catch here is, Ellie Gleam is asking, if so you can bring the transmitter to my house and I'll control it from there. So technically it can be anything. That's what I'm saying. It can be triggered by anything. So far as the LoRa devices are in the range of a LoRa network and the gateway is connected to the internet or cloud connected, you can literally control anything from anywhere. There is actually an interesting thing from Amazon, which is called the Amazon Sidewalk, and I think there are lots of the XIAOs and some of the new tracker devices can do that. It's some form of a LoRa protocol, but with Microsoft proprietary tweaks on it. And what that does is it allows you to control your devices without internet, literally without internet. This is because every Amazon device, every Amazon Alexa device has the ability to be a sidewalk node, part of the mesh, right? So we'll talk of a mesh is like every device has its own, it's like a combination of small devices that are connected to it, right? So if, let's say, I have a number of Amazon Alexa devices in my house and I opting to be part of the sidewalk protocol, sidewalk communication, if I enable that, it means that someone close to my house can actually use their app to turn on the lights in their house if they don't have, even where they don't have internet. That is because that command is going to go through my Alexa devices. My Alexa device is going to send a command to the the Amazon cloud, because at that point my devices are connected to the internet, and then that command will be sent to the people. Yeah, so like a lot of repeaters. Yes, see it that way, because most of the meshes are, yes, exactly. So see the mesh as, technically, yes, you have, so every node can be part of the mesh, and that's one of the unique things about LoRa. If you want to create a LoRaWAN mesh, you can do that as well. So the data meant for a particular node can hop around until it gets to the destination, but then the effective way is to use the LoRa gateway, which pretty much can send the command across. So that is what we have tried to achieve here right now. So there isn't any physical cable connecting the two of them. They are not going over Wi-Fi. They are not going technically over the internet within the effective, let's say, network or range of the LoRa modules. They're able to transmit stuff. So this doesn't require internet. So there might be situations or circumstances where you want to do this and you don't want to go through or go to the internet, right? So maybe you're building a community traffic light system, community street light system, which you want them to be smart, but they can communicate over LoRa, right? And so they can send telemetry data amongst themselves before it gets to the end node. So yeah, so if I do yellow, it just sends it and yellow comes on. If I do green, then it will just go in and turn on the green light. As you can see, if you do red again, that's going to, go back and send it to the red. So a little of the debounce, and then that comes. So now let's go and take a look at the code. So let's go to my desktop. And yeah, keep your questions coming. If you have any questions, let me know. So let's do this. So I'm going to start with the transmitter, which is the buttons. So we're going to open this, and first of all, I'm going to show you. So let's bring this here, and I'll show you the schematics, and then I'll walk you through the code. So this is the schematic for the transmitter. It says, does the physical barrier affect it? Let's address this question from Eric Plim. Yes. So to answer your question, Eric Plim, yes, attenuation always affects network connectivity. So that is why most times if you're deploying LoRa, they will tell you that in the rural areas, LoRa can go as far as 15, 20, 15 kilometers or even more, because there isn't a lot of obstruction in the, in the rural areas. Like there are no high-rise building, tall buildings, glasses, concrete, there's no stuff like that. But then if you come to the urban areas, yes, urban areas would have like high-rise building, glasses, all these things. They affect, the distance or the range of your LoRa connectivity. So it's good to have, a good deployment, test it out, look at the line of sight, look at the area, how dense the area is. All these things sometimes mostly affect the setup of your LoRa devices. So I hope that answered your question, Eliklim. So this is how we set it up, all right? So we have the red, yellow, and blue buttons connected through a resistor, and down we have the common, we have a common ground and power, as you can see that for all of them. And this is connected to at this point, connected to the LoRa module on the ESP. So this is very basic. This is very simple. This is a very simple setup. So let's go and look at the code. So let me see if I can get this a bit up for you guys to see. Yeah, so yeah, software serial, we're using a software serial to interact with it, setting it up, and then we're defining LoRa module configurations. This is the band 915. So if you are, let's say, so this is the US. If you can also use the 868, which is EU and Africa, which we use. You can set up the LoRa network ID. So this is the same. This has to be the same for your transmitter and receiver. So now, if we had a third node setup, okay, if we had a third node setup and they were also listening on the same LoRa network ID 7, it means that they would also be receiving the commands coming from the transmitter, in this case buttons, all right? And then you can have the LoRa address, which is the receivers, the transmitter's address, all right? So 126. So we know the LoRa module sending it. And then we're just setting our RX and transmission and receiving pin 26 and pin 25. We are setting up our software serial to allow us to communicate via the set LoRa pins, right? So transmit, receive. We're setting that there. And then we have a variable here to store our, to set the data length. And we have the string for red light, yellow light, and green light. They are all variables. And if you've been doing Arduino setup for some time, this one here is a very common one. So all we are doing now is setting our serial with a baud rate of 115.200. That's a baud rate. And then we are setting our LoRa to also begin at the same baud rate, and setting, we're giving a second for it to, set up. And then we are setting the red, yellow, and green pins, right? We're setting them as inputs, right? As input to receive that information. And then we are configuring the LoRa module again. So these commands are just, so AT first, the LoRa AT command is just to check to see if your LoRa module is working. So when you send an AT command, it's going to respond with an OK, and that tells you it's fine. Then you use the AT plus band equals, and what you're doing here is you are setting the LoRa band. Remember, we set the LoRa band up here in this. There you go. We set it in the variable here. So we're setting the LoRa band, we're setting the address and the network ID. So the AT plus address plus network ID plus band, that is how you set it. And always, you can also do something like AT plus address and then question mark. That is querying. You want to see what the current value is. It's a good thing to do. So in the setup section, basically that is what we're doing, right? And then now we are setting we're reading the input of all the buttons. So button 1, button 2, button 3. If button 1 is pressed, right, in the serial, let's see, in the serial, we're just saying, hey, red button is pressed, and then we're reading the red light, setting the data length, and then we are sending the LoRa data, right? We're sending it. And then the same thing, so the same thing for button 2, button 3, and this is the function we're using to send the data. So it gets the sensor value and then the value length. So this is just setting the message. So AT send to this, right? We're sending and say it's coming from this, comma, this is a value, this is a sensor value, and then it's just a line. And then we're printing the message, we're saying the message has been sent, and we're waiting for 250 milliseconds. So as you can see, very simple. Now, this is just to show you how simple it is to use a LoRa module and send using AT commands to send it. So this could be sending temperature. So at some point you could have probably connected a temperature humidity sensor somewhere, read a value, and then use your send data to send the temperature or humidity value to, you know, your LoRa gateway or your another LoRa node, right? So this here is the transmitter, right? Now let's go ahead and look at the receiver, the traffic light. So first of all, let me open the schematic and show you. So for this as well, this is a schematic, very simple, and we're using fitting for the schematics. So again, we have a LoRa module connected to the traffic light, and then to the ESP32 connected to it. So if you look at it, the red, yellow, and green connect to their respective pins. I see here we have the pins 22, 25, and all that also correct, and then we have it connected to the LoRa. Now let's take a look at the code. Also very basic and simple here. Let me bring this, and yeah, feel free to, and yes, this code I'll share the GitHub repo for you to go and, you know, copy it. So in a similar way, in a similar function, we have as you can see, the same thing. We're setting the LoRa band, the LoRa network ID. So you see that the network ID is the same. In this case, we're saying it is what, 621, right? And then again, we're defining red, yellow, green, the pins. These are the pins for the LEDs, the traffic light LED. Again, setting the pins for the receive. So this transmitter and receiver code here, that's what we're using the software serial to control, right? Again, same thing, setting it up, serial, setting up the serial monitor, setting up, you know, so LoRa received the begin. We're also waiting to receive serial communication from the LoRa modules, and then we're also waiting 1000 milliseconds. So then we're setting the red, yellow, and green pins to output, which means they're going to output some data when they receive it from our side. And then again, just setting it. So LoRa print again. So we are setting up the LoRa module, we're setting the band, setting the address, and the network ID, the same way we did. And you can see we just loop check serial, and this is the definition of the check serial function. So we check to see if we have received any string, and then if we receive it, we just process we process the data that we've received. So the data in, we get the value of the data, and then we just, you know, stream it out to see the various. So here we have a code for temperature humidity we are not using, but that's for temperature humidity setting we had in a different application, so we borrowed the code. But this is it. If the command is red, it's 1, then we are setting the red on, and we are turning off the yellow and the green. In the same way, if it receives a yellow command, then we are turning the yellow on, and then we are turning the red and the green off. This is how we chose to implement or set our own app. All right. You could decide to say, hey, anytime I press it, just keep all the lights on and toggle them on and off as you want it. But we just chose to go with this one. And we have the get value function that's retrieving the value from the 80 commands that were sent. So as you can see, this is very basic, simple line of code, nothing crazy. That doesn't mean this is the code you're going to write if you're doing your implementation. Obviously, if you are sending or doing different data sets, your code might probably be a bit different, but this should set you up in doing basic LoRa to LoRa communication. All right. I hope it's giving you a picture of how this is happening. Now, this is one setup. We're going to go to another setup, leveraging on the the Seeed Studio XIAO. Hopefully we have time. Oh, there's 9 minutes. Anyway, let me show you the setup and I'll show you how that's also so functional. So just give me a sec. Let's do this. Actually, let's go to the bench so that you can see me work on this. So let's turn this one off. Okay, so let's go. So yeah. Let's power this. There we go. Okay. All right. So what you're seeing here right now, this is the main someone say this is the control, right? So this here has the E5 LoRa module here, which is this one, and then it has a temperature humidity sensor, and then on this side it has a multi-channel gas sensor. So these sense a number of gases. So this here is the node that is collecting all the data. Let me see if I can bring it up for you to see here. So if you look closely up there, it's showing, come on. It's showing, let me see if I can get this. This is why, you know what? This is why I like this in my camera. Yeah, I need to get a better camera for my bench. So take a look at this. There you go. That's why I like this one. And yeah, my main camera is actually is an Insta360 link. So you see, this is the temperature, humidity, all that, alcohol, NO2, CO2, temperature, all that. You see, so this one here is, let's go back to the bench. So what this one is doing basically is just collecting, for now, it's just collecting the information. Okay, so temperature, humidity data, the multi-gas sensor. Now we have another setup here, and this one is just has the LoRa module. Now what we wanted to mimic or show was the one we show on the bench collects the data and then sends the data to this one, which could be the receiver, or which could be the one that's going to display it. We didn't connect the LCD to it, but we're just going to show the values on this one. All right, so let me get power to this one as well, and then all right, yeah, hopefully I can. So let's go. So yep, so now we can take a look at this. So this is the master, this is the slave. Come on, I wish I could easily do this. So let me show you. Let me use the main camera, because the main camera is much clearer to show you this, and I'll walk you through the code. So this is the one with all the sensors. If you look closely, it says the humidity is 93 point something, and I think the temperature is 20 something. Yeah, 25, and then alcohol is 5. There you go. Alcohol is 587, and then NO2 is 296. So this is just it's sending it, and then now you can look at here. So it's sending the data as it's reading it to this one, and this one is also displaying it right here. Temperature, as you can see, 29, humidity 91, CO2 56, alcohol. So all we've done is, this is the node, the one with the sensor is sending the data to this one, and this one is displaying. So this one could also be a control system, which takes it, access the data, and sends a command. Hey, shut down the CO2 valve, open the CO2 valve, do something. It's trying the factory, in a factory setting, right? You can see that. Eliclim has a question. Eliclim says, is there any particular reason you choose to use you chose to use AT commands rather than the Arduino LoRa? Good question. So basically, under the covers, almost all the common LoRa modules speak AT commands, right? It is the easiest way to set up your LoRa command. There was no preference. We could have used the Arduino LoRa modules, but then the modules we're using, we're having some challenges with the code. We're still working on it though. We're still trying to fine tune the code base. But I just wanted it to be very basic so that whether you are using a different LoRa module or something, you could just use basic AT commands. At the heart of all those libraries or packages are AT commands in the background, right? But that's why there wasn't any specific reason. We just wanted to make it very easy for everyone to literally follow and understand. So that's why we use that. So Eliclim, I hope that answers your question. So let's quickly look at 2 minutes. Let's quickly look at the code for that one, for the E5. So this would be specific to let's go to the deck. So this is going to be specific to Seeed Studio. So let's go here. Let me bring the Seed. So the master, I'm going to just open both master and slave, and then we'll go through the code as well. And the schematics is also the same thing, right? It's just we are connecting. Let's quickly just show the schematic. It's the same thing here, right? So the node, the LoRa module is connected to the UART, and then it's the same thing, A and B receiving, and then we have so we connected temperature, humidity to it, and write the code. So let's look at the code. Yes, I also have challenges with the setting libraries. Yes. So it's something we've noticed, and Seeed Studio, it's something I also noticed. Sometimes, Seeed has its own default libraries to use, but sometimes depending on the module you buy, if you download the packages, some of it doesn't work, so you have to resort in trying to find other libraries that work. So in our case, we just chose to use the basic AT commands to make it work, right? So yeah, if you're having any challenge, just reach out after the show and then we'll try to help you with that, right? So here, the same thing, including DHT 11, and then we have this is a multi-gas sensor library we're using over the wire. This library, I'm not sure we even used it. It's for the display, right? This library is for the display on the host, the XIAO host, defining the temperature, humidity pin. So here we're setting up the DHT, we're setting up the gas sensor, we're setting up the screen, and pretty much this is going to be the receive command and what we're going to receive. So we have one for the data, NO2, alcohol, CO2. Those will coming as string, and we have for temperature, humidity will coming as numbers. And then yeah, basically setting the two serial monitors so that we can see what's happening, setting up the gas sensors, the DHT, the screen. So this U8x8 is for the screen, the small screen you saw on the host, and then pretty much delaying. And again, as you can see, we're just setting the XIAO to the test mode, waiting, and then the pretty much loop is the same. We read the value from the gas sensor, we print it, we read the value from the alcohols, the sensors, the various gases, we just print them, and then we read the temperature, humidity from the DHC temperature, store them as float, and then we're printing them. Then we go ahead and set them on the screen. So this is how we are printing them on the OLED screen, and then after a while, we just write it. So you can see that now this is where this command here is what we are using to send it to the other ESP, the other LoRa module, right? So this is the master. And then now let's take a look at the receiving end, which is just the one that shows the data it receives. So pretty much almost similar concept. As you can see, the same thing, including the library, and then we have setting it up. The data received is what we're going to receive. Setting 2 serial monitors, also writing a test and making sure we're setting the LoRa module to receive packets. And then again, we set up the OLED, and then here, quite simple. So it's just, while there's data available, we're just writing it to the serial, and then showing that, because we're sending the data via hex, so we're converting it, and then we are printing it and showing it on the screen, right? So that's basically what we did. Very simple code that allows you to send, especially from if you're using Seeed Studio or you're using any generic LoRa module. Well, thank you so much, all of you that joined. That is what time will permit us. 9:1 today. We've done it. We'll stick to our time, and that excites me. So thank you so much for making a date with me today on the part 2. Part 3 will be the next episode, where we will now see how to send this data to a LoRa gateway. So actually, in part 3, we're going to set up a mouse site LoRa gateway. We'll set up the mouse-side LoRa gateway to speak to Microsoft Azure using IoT Hub. So that'll be what we'll do in the next episode. And then once we set it up to speak to IoT Hub, in the following episode, we'll now see sending the same sensor data to the gateway, and the gateway will send it to IoT Hub, where we can pretty much do any analytics or stuff we want to do to it. Well, thank you very much. Like I always say, smash this subscribe button, join the YouTube channel. Let's grow the channel. And then also, if you have any questions, let me just reach out to me, and I'll try and help you sort that out. With that said, we've come to an end of another thrilling episode. Stay blessed, be good, enjoy the best of the season. Merry Christmas and a prosperous new year. Let's hope that the new year brings us good fortunes, good tidings, and the show will grow bigger and bigger, and we can make the world a better place through technology. With that said, I still remain yours truly, Samuel Adranyi. Make a date with me next week for another episode of this. Let's continue to learn, let's continue to share, and let's continue to be safe. I'll catch you next week, and I'm out. Thank you very much.